Let's move on to a new chapter called Speed, Time and Distance. So we use the concept of speed, time and distance in a lot of places in our day-to-day life, right? So imagine that you're traveling by a car and you're going from one place to another place. And you are saying that you're traveling in a speed of like say 40 kilometer per hour or let's say 60 kilometer per hour. So what does this 40 kilometer per hour and 60 kilometer per hour mean to you? So let's see what all these things, what is speed, what is time and what is distance and how do we use them, how do we calculate them. Let's learn all these things in this chapter. So first let's talk about distance. So what is distance? Say that I am at a point here and I'm at a point A. Now I need to reach a point B which is situated around 100 meters apart. So what is the distance traveled by me to reach from A to the point B? Or what is the path which I chose through to travel to reach from A to B? Now the length of the path which I chose to travel is called as the distance. So if the length of the path is 100 meters, I call that path as 100 meters. Now here we could see an example here. See, this is a dorm room which is at the axis, this is the x-axis and we have a dorm room at x equal to 0. Now 2 units apart we have the physics lab, right? Let's say this is physics lab, and then we have a library at 3 meters or 3 units away from the dorm room. Now in -1 distance, what is -1? Minus indicates it's in the opposite side, okay? So this is in the positive side and this is in the negative side. So minus indicates that it is in the opposite direction. So in the opposite direction, when we travel 1 unit, we reach the cafeteria here. So what is the distance between the physics lab and the library? It's basically 1 unit. How? Because from dorm to library, it's 3 units. From dorm to physics lab, it's 2 units, and we subtract it and we get 1 unit, right? Now let's talk about the unit of distance. So how do we measure distance? First of all, let's say we have centimeters, we have meters, we have kilometers. When it's about the length, right? Or have you ever heard someone say that, instead of it's 35 kilometers, have you heard anyone say it's 3,500 meters? No, because it makes no sense, right? Why should we use 3,500 instead of 35 kilometers, right? So we have different units to express the distance. So we have centimeters, millimeters, millimeter is smaller than centimeter. Then we have meters, we have kilometers and a lot of things, right? So the standard unit which we use to measure the distance is meter, right? Now this is all about distance. Now let's talk about time. So time have various concepts, right? I mean, everything is dependent on time. Like time is actually explained as the 4th dimension by a lot of people. But here in the Newtonian mechanics, time is actually the duration, right? Time is actually said to be the duration of an event. It's the measurement of the duration of an event. Or otherwise, we could say it as if I'm traveling from one place to another, the duration which it takes for me to reach there from here is called the amount of time for traveling, right? Now this is the concept of time. And the standard unit of time is seconds here, right? Now, we all see a clock, we know the hour hands, we know the seconds hand, we know the minutes hand, right? So we could convert time into seconds, like hours into seconds, we could convert minute into seconds, and we all know the conversions, right? We know that 1 hour is equal to 60 minutes or 1 minute is equal to 60 seconds, right? Minutes can be denoted as this mark and seconds can be denoted as this, right? Now, let's say 1 hour is equal to 60 minutes and 1 minute equal to 60 seconds. So how many seconds are there in an hour? We could write it as 1 hour is equal to 60 into 60 seconds, which is 3,600 seconds, right? So we could use this standard thing, which is 1 hour equal to 60 minutes, 1 minute equal to 60 seconds, to do various conversions from hour to minute, minute to second, second to hour. Anything we have, we just substitute here and we get the answer. Now, let's talk about speed. What is speed? Basically, say that I'm traveling from one point to another point, or I'm traveling at a place which is 1 kilometer far away from my place, right? Now, I reach there in 5 minutes, right? Now, what is my speed? How do I calculate my speed? So basically, speed is defined as the rate of the distance covered. So at what rate am I covering the distance between my place and the other place, the rate of change in distance, or in what rate am I covering the distance? From here you can see that I'm going from here to here, right? Now, I just went from here to here. So what is the rate at which I'm going from here to there? That is called the speed of an object. So let's say we have we are going from here to here, and this is the distance, and I'm taking t amount of time to travel here. So we could say that my speed is the amount of distance covered divided by time. So what is speed? Speed is the rate at which a distance is covered. What does the term rate means? Rate means, at what, according to time, how much is it changing, right? So speed is the rate of change of distance by time. Or we could say speed is equal to let's say speed is equal to distance covered by time. Got it? Now, let's see some relationship between time, speed and distance. We know that speed is equal to distance by time, right? Which I told you right now. Now, how do we calculate the distance? Distance is equal to speed into time. Got it? So we could say that speed is equal to distance. I'm denoting distance by d, speed by s, and time by t. So speed is equal to distance by time, right? Now time is equal to distance by speed, right? Now what is distance? Distance is equal to speed into time. Got it? Yeah. Now let's talk about average speed. What is average speed? Let's say that I have a particular distance to cover. Okay. So now I'm taking half of the distance and I'm walking in one speed. And then after that, I'm changing my speed to another speed and I'm finishing the distance. So in this distance, I've divided two intervals, where in one interval, my speed is one thing, and in the next interval, my speed is the next thing, right? So let's say we have 5 meter per second, I was walking in 5 meter per second. And when I covered half of the distance, I changed it into 2 meter per second, okay? So what is my average? How do we calculate the average speed? The equation for average speed is 2 into A into B divided by A plus B. So what is A and B here? A and B is my different speeds. Okay. Now this is about average speed. Now let's talk about conversions. Say that we have to convert meter per second to kilometer per hour. Okay. So how did we get the unit as meter per second? Meter per second is the unit of speed. Unit of speed is meter per second or kilometer per hour, right? So how did we get it? Because speed is equal to distance by time. Now distance is, the unit of distance is meter and the unit of time is seconds. So we get the unit of speed as meter per second, right? Now kilometer per hour is another unit of speed, because kilometer is again distance and hour is time. Okay. Now, how do we convert meter per second to kilometer per hour? So, let's see. 1 kilometer is equal to 1000 meters, right? And 1 hour is equal to 3600 seconds, right? So let's say what is 1 kilometer per hour? 1 kilometer per hour is equal to 1000 meters per 3600 seconds. Is it clear? Now we could cancel these two out, and dividing by 2 I get 5 and 18 here. So we get that 1 kilometer per hour is equal to 5 by 18 meter per second, right? So if we have to convert meter per second to kilometer per hour, we multiply it by 18 by 5. How did that happen? So here we got that 1 kilometer per hour is equal to 5 by 18 meter per second, right? Now 1 meter per second would be equal to 18 by 5 kilometer per hour, right? So to convert meter per second to kilometer per hour, we multiply it by 18 by 5. Now to convert kilometer per hour to meter per second, we multiply it by 5 by 18, right? Yeah. Now relative speed. So let's say that I have a person who is working with me who walks way faster than me, okay? And I am a person who walks very slow. Let's say that my speed is 5 meter per or 2 meter per second, and that person's speed is 4 meter per second, okay? So what is the relative speed? Like when we both are walking together towards the same direction, the relative speed of us, that is my speed relative to the other person's speed, or that person's speed compared to my speed, what is that? That is that person's speed minus my speed, right? That is, okay, we are finding the average. Here, let's say I am walking in 2 meter per second and that person is walking in 5 meter per second. So what is the average here, or what is the relative speed here, or what do I see as this person is moving? You know the situation where we are sitting in a stationary, like a bus or a train or a car which is in rest. Okay, in rest means there is no motion, that is zero speed. So we are just sitting stationarily, and we have a vehicle which is right next to us, and it starts moving and we get an illusion that we are moving. Have you ever had that thing? So that is because of the relative speed. Because now if I'm moving in 2 meter per second and the other person is moving in 5 meter per second, the relative speed, or I would see that person moving in what speed? That would be, I would see them moving in 3 meter per second. Why? It's the difference between them. Okay. Now that person would see me moving in what speed? Again, 3 meter per second in the opposite direction, right? So if we are moving in the same direction, it would be a minus b kilometer per hour. And if we are moving in the opposite direction, I am moving here, he is moving here. So it's 2 meter per second and 5 meter per second. Now the relative speed, right? So according to me, that person would be moving in 5 plus 2, that is 7 kilometer per hour or meter per second, opposite of me, right? And according to the other person, again, I am moving 7 meter per second opposite of her, right? That is the concept of relative speed. Now, let's see some other equations which would be very useful to solve our problems. If a man changes his speed in the ratio A is to B, then the ratio of time taken becomes B is to A. How come? We know that speed is equal to distance by time. So he is changing his speed in the ratio A is to B, that is A by B. Then it is the inverse here, so it becomes the ratio B by A. Okay. The distance covered by train in passing a pole or a standing man or a signal post or any other object of negligible length is equal to the length of the train. So let's say that there is a pole. There is a pole here and a train. You know the trains are very long, right? So a train is moving here in front of the pole, right? So the the size of this or the distance covered by this pole is really negligible when it compares to the length of train. So when a train is moving in front of this pole, we neglect the distance covered by the distance of the pole, but we just take the distance covered to be the length of the train. Why? So this is the pole. The train is moving. So what is the distance covered by the train? It is the length of the train, right? Yeah. Now, if a train passes a stationary object having some length, then the distance covered by train is equal to the length of the train and that particular stationary object which is passing. So, in this case, we have a bridge here, right? We have a bridge here and then a train is passing through here. So, what is the total distance traveled by the train? It is the length of the train and the length of the bridge or the platform which it is passing through, because it's a particular comparative length, right? When it's a pole, what is the distance when it compared to the train? It is negligible. Now when it's a bridge, we have a lot of distance, and when the train is covering through here, we could see that the total distance covered by the train is actually the length of the train plus the length of the bridge here, right? Now, if two trains of length x and y kilometers are moving in opposite directions with the speed u and v respectively, then time taken by the trains to cross each other is equal to sum of lengths by sum of speeds. How would we get it? It is relative speed. Relative speeds in opposite direction means it's the sum u plus v. I'm taking, or x plus y, anything, right? Okay, we are taking x and y to be the length of first train and second train. Now, speed is u and v of the first train and the second train. So, what is time? As we mentioned earlier, we know that speed is equal to distance by time and time is equal to distance by speed. So, time is equal to distance by speed. Now, what is the total difference? It is moving in the opposite direction. So, we have x plus y divided by the speed. It's as it is in the opposite direction, we use the u plus v. Now, if the train are moving in the same direction, then the time taken by faster train to cross the slower train, it would be the sum of length, obviously, because we have two trains in the same direction, that is x plus y divided by the difference of speed. Why? It is moving in the same direction. So, we will take the difference of speed, right? Now, this is all about the concepts of speed, time and distance. So, basically, we have talked about what distance is, and the unit of distance is meter. Then what is time? The standard unit of time is second. And what is speed? Speed is the rate at which the distance is covered, and the unit of speed, the standard unit of speed is meter per second. Now we know the relation between speed, distance and time. Now we talked about average speed, like that I'm traveling from one point to another. Half the midway I changed my speed to another speed. So the average speed would be 2ab by a plus b. Now we learned how to convert from meter per second to kilometer per hour and kilometer per hour to meter per second. Now we have relative speed, that is one object speed relative to the other object, right? Now we have the cases where the train is passing through. What is the distance when a train is passing in front of a pole? What is the distance when it's passing through a bridge? Now then we talked about, if a train x and y are crossing each other in opposite direction and in the same direction. So this is all about the chapter speed, distance and time.